Hello, everyone. Welcome to this evening's talk on the Beyond Spacetime colloquium series. Today we'll have Siska de Baerdemaeker, who's a postdoc at the University of Stockholm, working with Richard Dawid on a non-empirical confirmation in fundamental physics. Siska has done her undergraduate studies in physics and philosophy at KU Leuven in Belgium, as well as an MA degree in philosophy there. And she then went to Pittsburgh to do a PhD in history and philosophy of physics. She works of science, sorry. She works in the history and philosophy of cosmology and astrophysics primarily, but also in issues which have a broader significance in philosophy of science. She's published in philosophy of science and in studies in history and philosophy of modern physics. And I leave it at that. She's won prizes as well, and but I won't go into those details today. She will be talking about confirming MOND. Please.
Question mark. The question mark is important. Okay, thank you so much for having me. It's great to be here in Geneva. And I just want to say before I start, so this talk is indeed based on joint work with Richard Dawid. And I guess the motivation, oh no, the clicker stopped working again. There we go. The motivation for this talk, broadly construed, is, and for this project more generally, I guess, is perhaps to provide a little bit of a course correction when it comes to philosophy of dark matter. Recently, there's been an increased interest in philosophy of science for philosophy of dark matter, and this is great, I think, right? Bit of self-serving interest here. And I think there's like lots of interesting work to be done. But interestingly, a lot of the work on philosophy of dark matter so far has focused on an apparent debate in science between two sort of fundamentally differing hypotheses, dark matter and modified Newtonian dynamics, or MOND. And I'll say a little bit more about what these are in a little bit. And so here are some examples of the papers that have been published on MOND and dark matter. Some of these, like the ones by Michaela Massimi or Melissa Jacquard, take a neutral stance in the debate and are sort of focused on the conceptual foundations of it. But the majority of recent papers in the philosophical literature, so those, for example, by Merritt, McGough, and Milgram, sort of make an explicit defense of MOND in favor of dark matter. Note the majority of these authors, so these authors that are like explicitly defending MOND, all of them tend to actively research MOND themselves. And based on the philosophical literature alone, one might think that there is at minimum a controversy in scientific literature, and that, you know, we might actually be faced with a genuine case of scientific underdetermination in contemporary scientific practice. Now, this apparent controversy, although front and center in the philosophical literature, it's not as, it's almost completely absent in the scientific literature, I would wager. There, dark matter is very much part of the cosmological concordance model or standard model called Lambda-CDM, and it has been so for quite a while. And so this talk takes as a starting point the current situation in science as sort of significant enough evidence to investigate why the Mondian defense, which takes up, you know, quite a significant position in the philosophical debate, why somehow that hasn't found any traction in, or very little traction at least, in the scientific community. Richard and I, in our paper and in this talk, there's sort of two things that we defend or that we argue, and both of which I will try to highlight today. I won't be able to like go through the entire argument because of time constraints, but you know, I'll give you at least some idea. So the first thing that I want to establish right now is that in order to make sense of the Mondian defense, what we have to think of it in terms of the structure of a meta-empirical theory assessment. What is meta-empirical theory assessment? This was an idea that was introduced by Richard Dawid, and I'll also go a little bit over what it is in a second. And in fact, we think that if in order for the Mandians to defend the epistemic claim about their research project that they want to defend, one has to interpret their arguments in context of meta-empirical theory assessment. That's the first thing that I want to show. The second thing is that the Mondian appeal to meta-empirical theory assessment actually fails because it appeals to sort of unfounded scientificality conditions. So here is what the talk will look like. So I'll start with a brief recap of the debate between dark matter and MOND. I'll then introduce what meta-empirical theory assessment is. I'll then give sort of a brief reconstruction of the Mondian defense as an instance of meta-empirical theory assessment, or MEA. I will only give you like one example of the arguments that they give, but in our paper we identify 3, so I'm happy to talk about those in Q&A, for example. Okay, so let's start with the recap sort of the controversy between dark matter and MOND. Why was it introduced? How is MOND a rival theory to dark matter? And I'll go quite quickly. I know for the Geneva people here, I already talked about this afternoon. So I'm just going to hope that, like, for most of you, this is sort of familiar territory, but don't hesitate to like interrupt if anything's unclear, of course. So let me start. Right. So dark matter, once again, the funnel is here, is part of the current concordance model or standard model of cosmology. The model, Lambda-CDM, describes the evolution of the universe over 13.8 billion years. And at the largest scales, Lambda-CDM is highly successful in sort of modeling how, for example, structure formation takes place. Now, the success of Lambda-CDM depends in large part on its positing the existence of cold dark matter. That's what the CDM in Lambda-CDM stands for. And thanks to this positing of cold dark matter, Lambda-CDM can account for the aforementioned structure formation, but also the existence of dark matter is further supported by the abundance of the lightest elements. As a result of Big Bang nucleosynthesis, there's the cosmic microwave background and isotropies. There's strong gravitational lensing observations like the bullet cluster, et cetera, et cetera. So all in all, the list of empirical support for the existence of cold dark matter is quite long. Now, what is dark matter? Well, this pie chart describes the current energy density of the universe. In other words, sort of all of the stuff that's currently in the universe. And as you can see, about 5% is ordinary matter. This is sort of the stuff that is described by the current standard model of particle physics. So it's everything that we sort of know and see around us, including the Earth, Milky Way, stars in our Milky Way, etc. There's dark matter as well, which is responsible for approximately 27% of the current energy density of the universe. Basically, the summary to say about what we know about dark matter is that it's not predominantly constituted by anything currently described by the standard model of particle physics. Now, I have briefly listed some of the empirical evidence for the existence of dark matter already, but taking some quite serious historical shortcuts, I think one of the major generally accepted sources of evidence in favor of the existence of dark matter comes from the rotation curves and the work from Vera Rubin and Kent Ford. The first results of which were published in this paper from 1970. What Vera Rubin did was measure the rotational velocity of stars in a galaxy in function of their distance from the center. Here's one of the plots from the 1970 paper. And what you see is that at a far enough distance from the center, the rotation curve becomes more or less flat. Now, this observation is unexpected for the following reason, right? At galactic scales, it is expected that Newtonian dynamics holds. Moreover, based on like the luminosity of a galaxy, the visible or baryonic mass distribution was measured. Based on these factors together, it was expected that the galaxy rotation curves would show a decline in rotational velocity with increased distance from the galactic center, but that was not what was observed. One way to account for these anomalous rotation curves was to posit that the mass distribution needs to be changed, right? And so that amounts to basically saying that there needs to be additional dark matter present. And so today, physicists assume that galaxies sit in a dark matter halo, and that presence of that halo can help explain these flat galaxy rotation curves. But recall that there were sort of two elements going into the prediction of declining rotation curves. There was the mass distribution and Newtonian dynamics. So another option in the 1980s or 1970s and 80s to account for these galaxy rotation curves was to keep the mass distribution constant, think that like that's fine, but to posit that at least at galactic scales, Newtonian dynamics need modification. This is what was proposed by Mordechai Milgram in 3 papers from 1983. And Milgram proposed a modification to Newton's laws such that in the high gravitational acceleration regime, Newton's laws as we know and love them would be recovered. But for the low gravitational acceleration regime, like the outskirts of galaxies, they can be modified to recover the galaxy rotation curves. The proposed modification also allowed Milgram and other proponents of MOND, or Mandians as I will call them for short, to predict various correlations on galaxy scales that they claim are unexpected based on the dark matter hypothesis, but that somehow are natural consequences of the Mondian formalism. These include things, for those of you who are familiar, like the baryonic Tully-Fisher relation, the mass discrepancy acceleration relation, and so on. And the MOND hypothesis has really not taken off much in cosmology. And today I would wager that the majority of cosmologists sort of accept Lambda-CDM and work within the framework of Lambda-CDM and its associated dark matter hypothesis, sort of like straightforwardly, and don't really think about MOND all that much. Consider, for example, this quote from Dan Hooper, who's a dark matter researcher, when he gave the Tazi lecture on dark matter. Hooper says, MOND fails to successfully describe the observed features of galaxy clusters. So things like, for example, the bullet cluster. Other evidence, such as the cosmic microwave background anisotropies and large-scale structure, are not generally able to be addressed by MOND, as MOND represents a phenomenological modification of Newtonian dynamics, and thus is not applicable to questions addressed by general relativity, such as the expansion history of the universe. There are sort of multiple criticisms of MOND going on in this quote. There's a criticism that MOND fails to account for the observations on galaxy cluster or cosmological scales, observations that the dark matter hypothesis in context of Lambda-CDM can account for. Moreover, there currently still is no sort of broadly accepted and worked out relativistic version of MOND, that is a version of MOND that is actually compatible with general relativity. So MOND does not really fit with our current theories of standard physics, while dark matter actually slots in quite well, right? Now, as I mentioned at the beginning, right, there have been several papers in the philosophical literature about the MOND versus dark matter debate. And indeed, several of these papers, as I said, those by Mary McGowan Milgram himself, explicitly defend MOND as somehow better, more viable, more reliable than the dark matter hypothesis. And their defense tends to take a philosophical turn by appealing to views from philosophy of science. So then the question is, why is this Mondian appeal to philosophy of science not effective, right? There are sort of different options that you might sort of think about. One might be, well, maybe the majority of physicists is just not aware of philosophy of science. And in fact, if they were aware, they would work on MOND. Now, this obviously would require quite an extensive kind of argumentation. Another option is that somehow there's a problem with the sort of the appeal of MOND to philosophy of science, right? And so what I will try to argue is that the only plausible reconstruction of MOND of MOND's sort of philosophical arguments is in terms of meta-empirical theory confirmation or theory assessment. And regardless of whether or not one actually thinks that meta-empirical theory assessment is a plausible view on theory confirmation or theory assessment more generally, Richard and I tend to disagree with one another on some of this. Even to the standards of meta-empirical theory assessment, the Mondian argument is in fact flawed. Okay, so that's sort of going to be the overall argument that I'm going to try to show. So at this point, let me make an important preliminary note. If you read the philosophical papers written by a lot of the defenders of MOND that I had on the slides just now, it turns out that they often do frame their terms, their arguments in terms of Popperian or Lakatosian demarcation criteria. And they then aim to show that the dark matter hypothesis is not scientific, while MOND is in fact scientific, and that from the rejection of the dark matter hypothesis as being unscientific, there's somehow some increasing epistemic trust that we should have in the MOND hypothesis. And that MOND should be somehow preferred over dark matter. Now, on a strict reading of, for example, Popper, you can't really make this sort of epistemic leap that they try to make, right? Because Popper's point was more normative, right? Scientists are not allowed to construct unfalsifiable theories. And from the rejection of one theory as unfalsifiable, you can't really draw conclusions for another rivaling theory, right? And so you can't really draw implications for an alternative theory based on the rejection of one theory as just unfalsifiable. However, the Mandian claim is trying to make these kind of epistemic conclusions, right? As this quote from Merritt illustrates, he says, Milgram's hypothesis wins from the dark matter hypothesis. It is epistemically the preferred explanation, right? So at the minimum, it seems that the Mandian does want to draw some conclusions, at least, from the rejection of dark matter for the viability of MOND as a theory. And so in order to make sense of these Mandian arguments, we need to move beyond a strict Popperian or Lakatosian reading and use a different framework for theory assessment. And if we look at the arguments that the Mandians give, the framework that we think aligns structurally most closely with the Mandian arguments is that of meta-empirical theory assessment. Let me just say once again, what I'm saying here shouldn't necessarily be taken as an endorsement of meta-empirical theory assessment as a view on theory confirmation. Rather, the point here is that of the available views on theory confirmation, we believe that the Mandian defense aligns most closely with that of meta-empirical theory assessment. Even if proponents of MOND themselves might not at face value immediately agree with this reconstruction of their views. Okay, so let me briefly now introduce the ideas of meta-empirical theory assessment as they were developed by Dawid. Okay, so as I said, the arguments that I'm going to discuss were introduced by Dawid, originally in a book from 2013, to explain why string theory, despite lacking direct empirical confirmation, is so successful and considered a viable theory by scientists. According to Dawid, this is because there are certain meta-level observations that give scientists reasons to believe that there are no viable alternatives to string theory within string theory's intended domain. Note, Richard actually used the moniker non-empirical confirmation for these meta-level observations and the arguments that were based on them. He has since changed the name to better reflect that there are, in fact, empirical observations at the basis of these arguments, but these empirical observations lie at a different sort of level than usually thought of in scientific practice. They're sort of observations of scientific practice itself. And so he wanted to distinguish these observations from other considerations like theoretical virtues like simplicity, etc. So the concept of meta-empirical assessment actually extends the arguments that were taken to sort of confirm string theory to cases where there is empirical support for a theory. Dawid claims that certain meta-empirical observations are actually essential to generate trust in a scientific theory, even when there is empirical evidence available. The observations that he identifies are characteristics that can be expected if very few or no possible alternatives to the given theory exist. If there are many alternatives, however, these characteristics would be very improbable. So the meta-empirical characteristics, if these are observed, it can be expected that the number of possible alternatives, including unconceived alternatives, to a given theory is either very small or zero. And if one believes that there should be a scientific theory at all, then the fact that there are few alternatives makes it plausible that the theory that one has actually found is viable. And so this gives you reason to trust the viability of that theory, to trust that theory. Now, Dawid identifies three sort of observations, meta-level observations or characteristics that give reason to believe that there are few or no alternatives to a given theory, and that the theory that one has found is indeed viable. The first is the no alternatives argument, which is that despite considerable efforts, no alternative theory has been found so far that can account for the empirical regime of the given theory. There's the argument from unexpected explanatory success, which says that the theory is capable of explaining significantly more than what it was introduced to do. Note that in case of novel empirical prediction, the extra confirmation value that the theory receives from novel prediction compared to accommodation is based on this argument from unexpected explanatory success. And finally, there's the argument from meta-inductive success. If a theory fulfills both the no alternatives argument and the argument from unexpected explanatory success, and past theories that in the same field have satisfied both have turned out to be successful, that gives reason to trust the theory as well. So those very quickly sort of like what these three arguments are. Now, for each of these three, Dawid recognizes that it is possible to actually sort of give objections to them as to why that shouldn't like increase your trust in the viability of the theory. So like there's in isolation, it's easy to counter the no alternatives argument. You might say scientists just haven't done enough research in looking for an alternative, and that's why we haven't found an alternative. However, Dawid wagers that if all three of them are present, they actually provide a strong basis because they reinforce each other, such that it makes it believable that few or no alternatives, conceived or unconceived, exist to the current theory, and that that theory therefore should be trusted. Okay. Okay, so now so after that very brief sort of whirlwind introduction into meta-empirical theory assessment and dark matter versus MOND debate, let me now turn to actually applying these arguments from meta-empirical theory assessment to the Mandian defense. And as I said before, in the paper, Richard and I actually identified three separate arguments, two arguments that take the form of meta-empirical theory assessment, two arguments that support a no alternatives argument, and one argument from unexpected explanatory success. I don't have time to go through all three in this talk. Instead, what I'm going to focus on is one of the arguments supporting a no alternatives argument as an example. But let me just state here or assert that like the other two arguments all attempt to show the same thing, namely that MOND currently is the only known theory that can account for observations on galactic scales, and that it's unlikely that there will be a rival to the Mondian framework, to MOND. In other words, defenders of MOND aim to establish that when it comes to galactic scales, there's just MOND as like a possible theory, as a viable theory. Okay. As I mentioned, like in the previous section, the goal of meta-empirical theory assessment is to argue that it's plausible that there are few or no alternatives to a given theory. And one way to do so is through a no alternatives argument, which argues to this conclusion based on the fact that no alternatives to a theory have been found so far. Now, of course, there is an obvious obstacle to such a no alternatives argument in the case of MOND, right? MOND has a very well-established rival to be reckoned with, namely dark matter. So any no alternatives argument in favor of MOND has to be based on an argument that somehow the dark matter hypothesis is inadequate. And one way the Mandiants try to achieve this is by arguing that dark matter is just unscientific, and to give sort of epistemic import to this judgment, right? To actually draw conclusions for MOND from the rejection of dark matter as being unscientific. There are two levels at which the dark matter hypothesis, according to MOND, is unscientific. The first is dark matter as part of Lambda-CDM the cosmological concordance model. Defenders of MOND sometimes argue that Lambda-CDM is unscientific because it is unfalsifiable. The reason Lambda-CDM is unfalsifiable is because in order to derive predictions from the model, from Lambda-CDM for galactic scales, scientists need to create computer simulations that involve highly complex, nonlinear, hydrodynamical and other kinds of processes. And these simulations have so many free parameters that you can tune them at will to predict just about anything. So at galactic scales, Lambda-CDM is just unfalsifiable. Consider, for example, this quote by Merritt from a paper from 2017, where he argues that dark matter constitute a Popperian conventionalist stratagem. I never know how to pronounce this word, stratagem, I think. He says, when attempting to reproduce the rotation curve of an individual galaxy, the parameters describing the putative dark matter halo are typically varied arbitrarily in order to give the best fit to the data. In this limited sense, the dark matter hypothesis can be said to be non-falsifiable, since essentially any observed rotation curve can be fit by adjusting the assumed dark matter density appropriately. So this is just like the one quote sort of illustrating this point. Now, there's a second level at which dark matter is considered unfalsifiable by some of the defenders of MOND, which is the dark matter hypothesis itself. This has to do with the fact that today, what constitutes dark matter is to a large extent still a question mark, right? There are lots and lots of dark matter candidates that have been proposed, and there are lots of experiments trying to find or detect signatures of these dark matter candidates. But if scientists fail to find any of these candidates, they currently don't really consider that reason to abandon the dark matter hypothesis, given all of the cosmological evidence that we have in favor of it and the astrophysical evidence of it. And moreover, sort of the mass range for possible dark matter candidates today spans 95 orders of magnitude. So excluding one candidate dark matter for dark matter still leaves lots and lots and lots of parameter space to explore, right? But the Mandian complaint then is that, in fact, this makes the dark matter hypothesis unfalsifiable, because no matter what negative result any dark matter search comes up with, there will be a way to save the dark matter hypothesis, right? You might say it's not a WIMP. Well, if we've excluded most of the WIMP parameter space, we can move on to axions or primordial black holes or sterile neutrinos, et cetera, right? So this kind of argument we see, for example, in some of Stacey McGow's writing. He says, given what we know of cosmology today, non-baryonic dark matter must exist. But does it? We know there must be new physics, but of what kind? The existence of the ether was at least falsifiable. It is not obvious that CDM, cold dark matter, meets this standard, and we teeter on the brink of the definition of science. The existence of cold dark matter is confirmable. A clear laboratory detection of appropriate WIMPs. WIMP stands for weakly interacting massive particle. It's one of sort of the prime candidates for dark matter, although more and more negative results in searches for it have come up, and so it's coming under pressure. So the existence of cold dark matter is confirmable. A clear laboratory detection of appropriate WIMPs would suffice. However, the existence of dark matter is not falsifiable. If we fail to find WIMPs, maybe it is axions. If not axions, we are free to invent another form of dark matter, and another, and so on ad infinitum. CDM was invented for very good reasons. But if this hypothesis happens to be wrong, how do we tell? Okay. So the Mandiants want to be fair, however, on this second point. And they want to say that the unfalsifiability of dark matter is redeemable. Namely, if physicists, dark matter researchers would adopt a specific dark matter candidate, then the hypothesis would indeed become falsifiable. Because in that case, if scientists look for the candidate and they can't find it, they have to reject the entire dark matter hypothesis, right? That would make it into a falsifiable hypothesis. Of course, this approach isn't really possible to dark matter researchers, because for dark matter researchers, this is kind of, for the cold dark matter hypothesis, this is kind of a non-starter, right? none of the current dark matter candidates have gained sufficient theoretical or empirical support to permit being adopted as the dark matter candidate. In fact, the reasoning in dark matter research seems to be exactly reversed, right? No specific particle dark matter candidate or something else will be adopted without a convincing detection of that particle in the first place, right? So this offered route to scientificality for dark matter is basically closed from the start. Now, there's one final part to this no alternatives argument. So far, I've reconstructed the Mondian argument that dark matter is unscientific because it is unfalsifiable. But is MOND falsifiable and therefore scientific? Right? After all, MOND itself was introduced to accommodate the anomalous rotation curves, just like dark matter. And so why, if dark matter is an example of an ad hoc but unfalsifiable hypothesis, why isn't MOND an instance of this kind of ad hoc reasoning? Defenders of MOND recognize this concern, but they argue that since their initial introduction, MOND and dark matter have seen very different developments. While dark matter has sort of remained stuck in unfalsifiability, MOND has, according to them, given rise to various risky predictions that have indeed been confirmed. Consider again this quote from Merritt, which I quoted part of earlier. Note that the prediction of the baryonic Tully-Fisher relation of Milgrams is refutable. It could, in principle, have been found to be incorrect. By contrast, the standard model prediction that dark matter particles are passing through an earthbound laboratory is not refutable, since nothing whatsoever is known about the properties of the putative dark particles. A failure to detect them might simply mean that their cross-section for interaction with normal matter is very small, and that, in fact, is the explanation that standard model cosmologists currently promote. On these grounds, as well, Milgram's hypothesis wins. It is epistemically the preferred explanation. So MOND indeed is scientific, while dark matter is not. And so this means MOND is the only possible theory on galactic scales, that there are no plausible alternatives to MOND, and we should therefore increase our trust in the viability of MOND. Okay, so far so good. I hope that with this last section, I at least have given you enough reason that it's at least plausible that the defense of MOND takes the structure of a meta-empirical theory assessment argument. That was my first goal. Now let me turn to my second goal, which is to provide an assessment of the Mandians' implicit appeal to meta-empirical theory assessment. Because if one is a proponent of meta-empirical theory assessment, should one accept the Mondian arguments? Note, there's something at stake here for defenders of meta-empirical theory assessment as well. Because if indeed the Mondian defense is convincing from the perspective of meta-empirical theory assessment, that would put meta-empirical theory assessment at odds with current scientific consensus. That's not an end-all, be-all counter-argument or objection to any philosophical view, of course, but at the very least, it sort of puts meta-empirical theory assessment in quite a complicated position, right? So let me now go through the assessment, and from the perspective of meta-empirical theory assessment, we actually think there's reason to reject the Mandians' implicit appeal to this framework. Because in order for this no alternatives arguments to work, the Mandians appeal to falsifiability as a scientificality condition. And from their appeal to falsifiability as a scientificality condition, they draw epistemic implications for which theory is most viable based on this scientificality condition, right? Now, from the perspective of meta-empirical theory assessment, this is a plausible argument that one might give, as long as there's some kind of foundation that you give to this condition of scientificality. In other words, there has to be some reason that can be given to expect that whatever the viable theory is in an intended domain, it will indeed satisfy this condition. So the question is that the case for falsifiability when it comes to physical theories of galaxy phenomenology? Do we have good reason to believe that whatever the viable theory on galaxy phenomenology is, it should be falsifiable? Well, there's two versions of unfalsifiability that can be distinguished in our and we call these absolute and transient unfalsifiability. a theory is absolutely unfalsifiable if it basically merely provides a parametrization of the empirical data within a particular intended domain without having any import whatsoever. In that case, there is no imaginable empirical data that could in principle falsify the theory's prediction. And this kind of absolute unfalsifiability as a demarcation criterion is indeed endorsed and relied upon by meta-empirical theory assessment. Because and so it's sort of endorsed by meta-empirical theory assessment. But there is also a different kind of unfalsifiability, which we call transient unfalsifiability. And a theory is only transiently unfalsifiable if it is currently not understood well enough, not specific enough, or not constrained enough in order to be able to derive testable predictions from that theory. But in case of transient unfalsifiability, better understanding further specifications or further database constraints would eventually lead to a falsifiable theory. And this kind of transient unfalsifiability cannot be used as the basis for a no alternatives argument. Now, which of these two versions of unfalsifiability applies to dark matter? At most, and this is like a very clear at most, what Mandiants can charge the dark matter hypothesis with, and again, let me stress that it's not even clear that they can charge the dark matter hypothesis with this much, but at most, what they can charge dark matter hypothesis with is transient unfalsifiability. Neither one of the arguments I laid out in the previous section supports a claim of absolute unfalsifiability. With regards to the complexity of simulations needed to derive predictions for galaxy scales, it is indeed true that nonlinear processes taking place on galactic scales make simulations of Lambda-CDM really complicated. But it doesn't mean that it is impossible to further develop them in order to these simulations, right? In order to actually gain sufficient understanding to make predictions for galactic scales. In fact, that's one of the main research programs in contemporary observational, in one of the research trends in current observational cosmology, which is building better and better understood simulations. With regards to the dark matter particle candidates, right? It is entirely possible that at some point there will be evidence from collider experiments, direct detection experiments, or astrophysical observations that lead scientists to adopt one model over one dark matter candidate over the other ones. And as the Mandians themselves admit, once a dark matter particle candidate, or like dark matter candidate, I guess broadly construed, has been accepted, the dark matter hypothesis does become falsifiable. So at most, right, dark matter can be charged with transient unfalsifiability. But importantly, a theory being transiently unfalsifiable is just saying something about scientists' current understanding, right? It does not reveal anything about the spectrum of all possible theories for a particular domain. But the goal of meta-empirical theory assessment, and indeed the locus of sort of where the confirmation of a theory can come from, according to meta-empirical theory assessment, is exactly the assessment of that spectrum of possible theories. And so the introduction of like transient unfalsifiability by proponents of MOND is overly restrictive and has no epistemic basis that could give rise to the confirmation of MOND over dark matter. And so the Mondian rejection of the dark matter hypothesis and the associated basis for an alternative argument fails. Okay. I've just given you sort of one example, and let me now of like how these appeals to meta-empirical theory confirmation might fail or theory assessment might fail. Let me briefly conclude. I started off with sort of an observation that many of the philosophical papers on dark matter are actually advocating for an adoption of MOND and the rejection of dark matter. And there was sort of a genuine puzzle, like why is this not taken up in the scientific literature? And when looking at the arguments in favor of MOND, there were two things that I tried to show. First, that the defense of MOND takes the structure in order to be able to make the claims that Mandians are wanting to make. The best way to sort of reconstruct their arguments is in terms of meta-empirical theory assessment, and then which was like introduced by Dawid, as I said. And that second, the Mondian appeal to meta-empirical theory assessment fails because it appeals to these scientificality conditions that don't provide the epistemic foundations that you need to do. And so I didn't really discuss the other two arguments or these further two instances of meta-empirical theory assessment. But from sort of the three together, I think the minimal conclusion is that within the framework of meta-empirical theory assessment, there's really no basis for the acceptance of MOND over dark matter, which perhaps can in part explain why the philosophical debate or the philosophical appeal has not taken off, in science. Thank you. And here's some reference.
Thank you very much. We'll have to find out whether the microphone will be strong enough if it's there for the people on Zoom to understand what we say. I see one hand up, so please, Niels, go ahead.
Hi, Siska.
Hi, Niels.
Hi.
I don't know where you are. I don't know if you can see me.
So physicists, at least relative to philosophers and especially historians of physics, tend to have a, let's call it a shorter academic memory, in the sense that they focus much more on very recent papers, like the last few years, 10 years. If something is around for 20 years, it's basically gospel, and as if it has always been around. So it's obviously a very simplistic caricature of science, but to the extent that it's true, it surprises me that when these physicists and the Mondians turn to philosophy, they suddenly, instead of going straight to the recent literature, like, oh, let's go back 80 years, right? So Sanders, Magot, Milgram, they don't get beyond Popper and Kuhn. And it's a bit amusing to see that Merritt, right, he starts out at the conference you and I were in Aachen, he starts out with Popper, and then he does a bit of Kuhn, and he writes a book on Lakatos, and now he has a paper on Feyerabend. And like, why does he not skip to the end? Yeah. So do you have any thoughts on, are they just lazy, or are they aware of the new stuff and realize it doesn't work so well, so they go to the old stuff? Or is modern philosophy of science less good at getting through to physicists than the classics? And hence, how should we go about improving that?
Oh, that's a good question. So let me say that anything that I will say next should not be taken as like lore, because I am not going to like psychologize the Mondian defenders of MOND or anything of the sort. I guess probably there is sort of, it is just a matter of fact that if it comes to philosophy of science, the sort of names that are broadly known and that are like often taught as well might be like Popper and Kuhn and Lakatos, you know. And so that might be part of the explanation. I guess maybe a way of sort of interpreting this kind of project is, you know, there are huge, like there, as I pointed out in the talk, right, there are reasons why these kind of arguments don't actually go through if you just stick to these older frameworks in philosophy of science. We try to give like what we think is the most plausible reconstruction in terms of a more recent view on theory assessment. But yeah, I'm not sure about, I think this is in general an interesting feature that in like, even aside from the debate about MOND, in general cosmologists seem, at least my perception of it is that they seem very interested in demarcation and the demarcation problem, but that discussion of the demarcation problem tends to not really go beyond Popper all that much. Yeah. And so it's an observation that I find interesting, but I don't really know what to do about it, aside from like trying to do work that maybe doesn't do that. I don't know. Yeah. Yeah.
Well done. Thanks.
Thanks, Niels.
So there is a concern that the people on Zoom don't hear us when we speak here, but let's give it a try. But please, why don't you ask your question and we see whether this is heard?
Yes, so my question was, why is actually the most proponent defending that the dark matter hypothesis is not scientific, and not just that both hypotheses are scientific, and that it's worth exploring the less explored view, which is MOND?
Yeah, another good question. So I guess one thing that I can say about this. So right, the question is like, why are they going like extremely the most aggressive route, which is MOND is not scientific. Dark matter is not scientific, rather than just saying we need both. Perhaps historically speaking, there is part of the concern that dark matter has become so dominant that sort of MOND doesn't really get all that much attention anymore, and it's sort of like you could see this as sort of like perhaps sort of a sort of a result of that historical fact. Let me say though that while this is like I think the most extreme version of the no alternatives argument that they give, the second no alternatives argument that we identify is in fact one that takes slightly more the route that you suggest, which is that, you know, suppose we think that both dark matter and MOND are in fact scientific, still dark matter cannot be an adequate rival for MOND because the kinds of explanations that it might offer for galaxy phenomenology are sort of inadequate. So there is sort of like a milder version no alternatives argument that is also present in their argumentation. Yeah, I might say that.
Mike.
Hi, Siska.
Hi, Mike.
Thanks for the talk. I have various different questions that I could ask, but one of them that I think is, I don't know, I worry that this might pit you against Richard. So maybe this
Go for it.
So one thing that historically meta-empirical theory assessment has gotten pushback for, as I understand it, is the preponderance of positive cases of it given, namely in string theory in which it was developed and then later in inflation and other avenues. Whereas, at least by my understanding, this is one of the first projects where conceivably we're seeing failures of arguments within the framework being provided. So by hypothesis or by your thesis, right, this meta-empirical theory assessment is what is going on by these Mondian proponents or the meta-Mondian advocates. And the arguments are in virtue of some further philosophical reasoning not going through. Mm-hmm. Can I understand this as placing further constraints on what the framework of MEA is capable of doing? Or is the move to be helping ourselves to somehow some meta epistemic framework, you know, in which we're embedding meta-empirical theory assessment as a particular tool?
So is the second option something like we're now doing like a meta level assessment of cases in which meta-empirical theory assessment is successful or not, and then drawing conclusions for the view itself?
Yes, although I will flag that if that is the route you want to go, I'm very worried about a regress.
Fair enough. So I think, well, I don't know. So Richard might disagree with me on this because, to be fair, this is a really good question and we haven't actually like talked about this. So this is just my take on this. What I take to be the case here is that if meta-empirical theory assessment would sort of align with the Mondian argumentation, sorry, I should say somebody on screen, then that would really create problems for the view on theory confirmation. Like I would take that actually as an argument against it as a view on theory confirmation, right? Because I think there's some minimal requirement for philosophical views that they take, or at least that's, I think that they at least take sort of scientific sort of standard views, like that they align with that to some extent, right? But I don't know, well, okay, the first question you said was, does this put constraints on what MEA might do? So what do you mean by that? Because what I think about this project is, or like what I think this project means for MEA, and I don't know if this is what you actually mean, but what I think this project means for MEA is that it at least shows like particular areas where this view needs further specification or further development, because there are instances where MEA applies where or like where people might appeal to meta-empirical theory assessment, but where their arguments shouldn't be effective, right? And sort of the specification of scientificality conditions is one example of that. And then of course you need more, like you need to give additional arguments for why particular scientificality conditions work and why other ones don't, why certain standards of explanations work and why others don't. So I don't know if that is what you meant with the first option. So yeah.
I think so. So I used the word constraint. What I was thinking, or what I had in mind, was a past charge against MEA is that it is it's too vague or unspecific, and so it can be a rallying point for various proponents of these different approaches, but it wasn't ever clear what wouldn't be good enough to count as these, and so it's constraining the sort of shape of what is a good or a proper MEA argument. And so I think that's the answer that you just gave.
Yeah, exactly. Yeah.
Great. Niels has a follow-up.
Yeah, I'm getting slightly worried about what you just said, that we're saying, right, either we apply this framework and it tells us MOND is not the way to go, great, or it turns out that it favors MOND, and then we should not use that framework, and because we don't want that conclusion. It seems a bit like, I mean, MOND cannot win, and so either you're begging the question, it seems, or it's not. What's the point of doing this work if you want to end up arguing against MOND anyway, right? And either we're already convinced of that anyway, or if these are the two options, then we're not going to be more convinced of it after applying this framework.
Well, Niels, I think the problem is that I think this is where you and I differ in opinion, is that I don't know whether we actually differ in opinion.
I'm not as Mondian as you think I am, but okay.
Sorry?
I'm not as Mondian as you think I am. Sure, go ahead.
Okay, good. That's good to hear. Anyway, what I think, it is a significant fact that MOND hasn't been taken on by the scientific community, right? And so in that sense, I think it can be granted that we can take that as a starting point for a philosophical examination as to why it might not be the case that MOND hasn't been taken on. So I think that in this particular, for this particular project, yeah, it is the case that MOND can't really win because in scientific practice, MOND hasn't won, right? I mean, that's sort of putting it in extreme terms, but like it hasn't been taken on. And so, as I said, if it ended up being the case that meta-empirical theory assessment would align with MOND and would actually say that like, actually MOND is the better confirmed theory and dark matter should be rejected, then I think the conclusion that you might draw from that, or the implication that you would draw from that, it would, like I said, it would put meta-empirical theory assessment in a really strange situation where they would have to be able to give an account as to why, nonetheless, that is not what actually happened in science, right? And so, yeah, I actually think that for this particular project, I would say, fair enough, Mandians can't really win.
Okay, thanks, that's helpful.
Thank you.
Nick.
Hi, yeah, thanks for this talk. That was very nice. Hey, good to see you. So I wanted to ask, could you clarify, so there were two things you said, and I don't think you tied them together, but I wanted to sort of, they seem to kind of clash a little bit. So one was, I've forgotten if it was Merritt's argument about, coming up with new candidates for dark matter, sort of with ad infinitum. And on the other hand, that sounds like an argument for absolute unfalsifiability rather than transient falsifiability. And I don't think you I understood what you were saying, your response that you gave, when you were saying it's at most transient, but do you have a sort of specific response to that argument? In that?
Yeah. So fair enough. So I think, right, they sort of say like you can keep coming up with dark matter candidates ad infinitum, but I think the reason why still that's an example of transient unfalsifiable, like right now, all we can say that is an example of, or like at most what we can say right now is that it could still very much be transient unfalsifiability, is because if there is indeed some detection of a dark matter candidate at some point or other, then that in and of itself would turn the dark matter hypothesis entirely into a falsifiable hypothesis. And so sort of making I think you are right though in saying that suppose we never ever come up with a detection of dark matter, doesn't then the charge of ad infinitum stand? I think in that case, the response will be like, there is still a sense in which all of the currently, like, in order to then still say this is like absolutely unfalsifiable, that is a very strong claim, sort of negating or almost ignoring all of the cosmological and astrophysical evidence that is available for dark matter, right? But I didn't say that explicitly in the talk, but I do think that would be like the response to that kind of, suppose there's never a positive result, like for a particle detection or something like that. Yeah.
It's my turn now.
Hi. Oh, yeah.
Hi.
Sorry.
Microphone. Thank you.
Go ahead.
Yeah, so good. Old curmudgeon that I am, I'm worried that, you know, maybe the charges put up by the Mandians might actually stick a little bit more than you might think, without that in any way establishing MOND as a really viable sort of scientific alternative to that. Because MOND, I think, to the extent to which I'm familiar with the debate, has its own set of problems and its own set of limitations. And as such, it may just not be as attractive as a research paradigm for researchers in the field. So the dark matter hypothesis seems to have to be more attractive for a number of reasons, but that is not, of course, enough to say that there isn't a problem. There is a problem in that it is unspecific enough. It's like a sort of a general idea that we know that there must be something more that gravitates. It's extremely vague or general as a hypothesis. And as such, it does have a problem of falsifiability. Of course, that, you know, unfalsifiability or unrefutability may be transient once we advance in our scientific project and become more specific and attribute additional properties to these, you know, to the dark matter candidates. But as such, you know, you could at the very least say that this is a serious scientific charge that points to an urgent and important task that defenders of dark matter have to somehow fulfill or complete. And I actually think that this might, you know, many people working in dark matter candidates might actually agree with that and say, yeah, sure, that's exactly what we're doing. And one more remark, if I may, as long as I have the microphone. It sounds in a way, it's somewhat parallel to the case of inflationary cosmology. Insofar as in inflationary cosmology, we have a general idea, a general kind of mechanism that is supposed to account for some perceived problem of a theory without it, but there lacks sort of a specific mechanism. We don't exactly know how inflation is supposed to work, what triggers it, what causes it. Is it an inflaton field? Is it this or that? And so on and so forth. And people have said, you know, given that it's so general in a way, it's hard to falsify inflationary cosmology because there's a gazillion models there. You know, there may be constraints up there that's going to rule out some of these models, but the sort of the general hypothesis as such has something unfalsifiable about it. And, you know, dark matter seems similar. There are good reasons to think that maybe we need something like dark matter, but it's so general that at that level, it's not really falsifiable because whatever we find, we just say like, okay, these are new constraints, we accept those, but, you know, as you know, Merit or somebody else would say, ad infinitum, we can still go on So there is this concern.
Okay. So, right. Let me say, first of all, so about the sort of first sort of point that you made, which was like, you know, even if we can't draw implications for MOND, there are still important challenges to dark matter in terms of like refining our simulations, identifying what constitutes dark matter, etc. I think fair enough, right? I don't think there's scientists right now out there, and at least I don't think that like science is done working on dark matter, that the dark matter problem has been solved. Not at all. That's why they keep proposing new projects, trying to like further develop astrophysical constraints, etc. And I think that's fair enough. However, on the parallel to inflation, I think there is sort of some pushback that I would want to give there, because there is a lot more observational and empirical support for the existence of cold dark matter than I would wager there is available for inflation. And that observational and empirical support is in a certain way actually quite specific in the kinds of constraints it puts on cold dark matter, right? And although there is still sort of a broad range of possibilities for what might constitute dark matter, at the same time, kicking out dark matter from cosmology right now would sort of basically mean that you cannot account for the cosmic microwave background, you cannot account for baryonic acoustic oscillations, you cannot account for structure formation, and so on and so on. And then and you can't account for like the bullet cluster on cluster scales and such. And so I think that's an important pushback against inflation, right? I think there's I won't like sort of, or pushback against sort of the parallel. Yeah, sorry, against the parallel with inflation. I think the case for cold dark matter is much, much, much stronger than the case for inflation, and doesn't quite qualify this unfalsifiability charge as clearly, because right, the predictions that you can derive from Lambda-CDM for say what the baryonic acoustic oscillations might look like, things like that, those are quite specific, and you know, could turn out to be wrong, and they weren't. So you know, yeah.
So as such, the model is really falsifiable, even in the absence of a specific candidate for dark matter.
I would wager that like on large scales, yes. And then on galactic scales, right, where like the hydrodynamical processes and such become relevant, that's where more work needs to be done in order to be able to derive certain specific predictions for galaxy dynamics and such. Yeah.
I don't see any other questions right now. But this.
Oh, let me bring you the mic.
Yeah, just a small follow-up on this. So you talked about, I mean, Chris asked about how much it was like eternal inflation. I was also thinking about the case between the heliocentric model and the geocentric model, how people gradually moved from geocentrism to heliocentrism. And it seems to me that we can't have a naive view of the process of falsification and of an hypothesis being falsifiable, because in history of science, we have cases where scientists came up with a good hypothesis, and at the time there was no way we could check it empirically. So it was literally unfalsifiable at the time, in the sense of provisionary sense, right? But do we want to say that it's not scientific?
Yeah.
That makes sense. I mean, the heliocentrist hypothesis was scientific even before we invented Newtonian mechanics. I mean, but we needed Newtonian mechanics to arrive to the stage where we were able to actually empirically assess the claim. So I'm just with you, and I think it's not like very charitable to say that it's not scientific because we don't know how to empirically assess the hypothesis.
Yeah, good. So I agree. Let me just say one thing that, like, to be sort of charitable to the Mondian defense, their argument about the unfalsifiability of cold dark matter is, while I still think it's not plausible, because, you know, at most it's transient unfalsifiability, it is not necessarily based on like time slices of like what, like if we just look at the status of the science today, right? There is sort of like a claim in which, like, you know, it's been around for 40 years and there's been so much looking, like so many searches for dark matter that have happened and none of them come up with a positive result. So like it is a little more charitable, like that's a little more charitable reconstruction. I still don't think the claim holds. Still don't think the argument goes through. But, you know, like it's a slightly more complicated view, perhaps, than just looking at like right now the status of dark matter. Yeah, so let me just say that. Yeah.
Okay, Mike has a question.
Hi again. So I'm still trying to, well, okay. I wonder how much of what's going on in some of this conversation, some of the Mondian conversation, and your retort to it, how much of this is a philosophical mirage? Not that you have a locus of disagreement, but the sort of terms in which the disagreement is getting cashed out. The entire debate, as you presented, and I think this is accurate, is my sense of it, is that the charge that Mandiants are leveraging against the dark matter group is, of course, about cold dark matter, because that is the feature of standard model cosmology. But in some sense, if they had cashed this out in terms of dark matter, simpliciter, it would be a much more obviously terrible argument, because of course we've placed lots of constraints. We've gotten it to be cold. We're very certain that it's not even a little bit warm. And yeah, there's self-interacting proposals, but like those are all super fringe, and you know, even the Mandians are reluctant to touch on those. They structure the debate entirely in terms of cold dark matter. Are we falling into a trap of just taking disjunctive predicates too seriously? Might be a way of setting this up, where if I can merely contemplate a way in which I can break apart the claim into a bunch of a disjunction of a bunch of simples, then I get to leverage a claim that it's going to be unfalsifiable, or not to focus too much on the specific example that you focused on in this talk, which is falsifiability. But just in general, it seems like in the background, there's a, I don't know, really Chris's connection to inflation is what sort of made me start to worry along these lines. I don't know, does that make sense?
Yeah. So just to sort of recap, like why you started to worry, and then see whether what I'm saying is in line with what you're thinking. So Chris was talking about inflation being so overly specific, overly general, overly general, and like permitting so many different models. And really the parallel to that would be dark matter as a whole would be sort of the parallel to inflation, the inflationary paradigm. However, in the dark matter case, in fact, there's been so many observations that have actually constrained it further and further and further to cold dark matter, and like additional constraints on the kinds of interactions that are possible, and like, you know, et cetera, et cetera. And so really the Mandians are sort of like stacking the deck in their philosophical favor, so to speak, by sort of kind of assuming that the only plausible alternative to MOND is cold dark matter, instead of sort of the broader non-baryonic, like, or matter, like dark matter as a whole. Is that the concern?
Yes, or almost. So then it goes one step further, I think, which is that are many of these intuitions now on both sides, so the Mandians, but then on also now how you and Ricardo are engaging with them. Are these arguments and the intuitions behind them going to be very sensitive to what we might have otherwise hoped would be somehow arbitrary relabelings of the situation at hand? Because if I treat sort of dark matter simpliciter, and now I can get this intuition going that we really have continually and successfully constrain down the space to just cold dark matter. But meanwhile, if I started with a picture of, dark matter is every possible particle realization of dark matter, and so shrinking down from all to just cold is just a measure zero set of those possible things that flips the intuition.
Yeah. So, yeah, I think so. Okay, I understand what you mean. I mean, I think this is sort of in part where I guess maybe part of the argument, at least that I presented today, can be taken as pushback against this kind of relabeling, right? Which is this idea that MOND is like, it could become, dark matter could become falsifiable if you specify a particular dark matter particle candidate. And sort of the pushback there is that like, but that's an unfair sort of like, that's just like a non-starter for dark matter. That's like an unfair description of what the actual situation in science is is like right now. But I hadn't thought about sort of extending it to like the restriction of the dark matter domain to cold dark matter is already sort of like a huge advancement in science, like in putting constraints on this thing that is dark matter. That if you look at theory space from that perspective, really like the range of all possible theories, there already is like a huge kind of limitation that's been placed on dark matter. That's a good point. Yeah, I don't know. I don't have much to say about this except for like, yes, good point. I don't know. Yeah, thanks. Yeah.
Okay, I have another question.
Mm-hmm.
I would like to, thank you. I would like to revisit the first part of your argument where you say that we should best think of the Mondian argument as made in the small number of publications, by Merritt and by McGow, I think it was, is really a case of an MEA. Of an NAA, so that there really are, and because I'm not sure, I don't remember all the quotes I've seen, but do they really say that there is no alternative to MOND? Are they really, because if I remember correctly, what they say is there are two alternatives, MOND and the standard model or dark matter hypothesis or something like that. And if we look into criteria or conditions of scientificality, MOND wins.
Yeah.
So it's superior, but they don't seem to be claiming that it's the only alternative, sort of the only game in town, do they?
Right. Okay. Yeah. Good question. So, first, let me say that I'm not necessarily saying that that this is like what the Mandians think they're arguing, or like how they think they are arguing. What Richard and I claim is that in order to make sense of their claim, you have to, like, in order to give sort of the strongest reconstruction of that claim, it has to be cashed out in terms of meta-empirical theory assessment. Now, that still raises the question about like, well, is that like to what extent is that accurate, right? They sort of argue for MOND in favor of dark matter, but does that necessarily imply that MOND is the only game in town? What we are sort of assuming here is that, and I think this is a fair assumption, but maybe people disagree with this. Like what we are sort of assuming is that, when we're working on galaxy, like looking at galaxy scales, the kinds of predictions that are made about dynamics there are derived, as I set it up, right, from Newtonian dynamics, and then mass estimates and mass distribution estimates, right? And so dark matter is like the game in town for changing the mass distribution. The other option then is to just change Newtonian dynamics. And I will say that I think as far like you might think, well, maybe there's other ways to modify Newtonian dynamics to MOND, right? I think there's sort of like further reasons why the Mandians would say that theirs is the most plausible modification of Newtonian dynamics. So one of the sort of positive arguments they give in favor of MOND is that it gives naturally predicts, by which they mean something like it sort of follows from the equations sort of quite clearly. a host of correlations on galaxy scales that, for example, all constrain the same acceleration parameter that is like sort of typical of MOND. And so they sort of make a comparison between like these independent lines of evidence for this one acceleration scale to, say, Perrin's arguments for atomism, right? And that's very much a kind of argument that is trying to say something like, that is not just saying like the rejection of dark matter leads to increased trust in MOND. It is also very much sort of like, and in addition to that, there is additional reasons why MOND is indeed the most plausible and most viable theory on these scales. Yeah, but I didn't talk about that in the talk. That's like an argument from unexpected explanatory success, I guess. Yeah.
But isn't there still, you say, the most viable, the most reasonable, the front runner? That doesn't seem to me to be the same thing as the only game in town.
Okay, so maybe that's more of a reflection of like the sort of general concern that I have about sort of assessing unconceived alternatives. But I think, yes, in terms of meta-empirical theory assessment, that would be good enough reason, like the combination of these arguments, these would amount to sort of reason to believe that it is the only game in town, or it's plausibly the only game in town. Obviously, there's still a way in which meta-empirical theory assessment is fallible as well, right?
Sure.
But that's sort of a general, yeah.
Okay, thank you. Nick has a question.
Oh, I was just following up on what you said. I mean, one could say the same about string theory not being the only game in town as well. Right? So that's
I will not get into that debate. That's something that you can like talk to Richard about, I guess. But yeah. Yeah.
So I think, but anyway, I think the point Chris is making is, yeah, no alternatives maybe is a little strong for what Richard, has exactly has in mind.
Yeah. I mean, I think that's more of a concern with meta-empirical theory assessment rather than, say, with like this particular instance of how the Mandians are arguing.
Fair enough, but we might conceive of the meta-empirical theory assessment as Richard conceived of it, when he wrote the book on string theory and the scientific method, is that maybe and I take that to be Nick's point, maybe he didn't mean strictly no alternatives. Of course, there are other alternatives.
But they're less adequate.
But, well, not just that. That's the conclusion where you would like to get at, maybe. But with accepting a certain general paradigm, maybe, or a certain kind of research program or research tradition, then, and in particular in the case of string theory, string theory seems to be the only way in which you can sort of generalize the particle physics paradigm in a way to include gravity. When you make certain assumptions about what the research tradition is and what it's supposed to be holding fixed, then once you have these additional constraints, then the remaining theories, there's really only one game in town. Yeah. Did you want to respond, or Lorenzo has a follow-up?
I don't. Maybe go. I don't know if there's anything particular I want to.
I mean, there's one thing I remember because I bought the book and we did a seminar on that, and I read multiple times, and I can pretty sure that what he will answer is the following: that he made the distinction between theories of quantum gravity and theories that unify all the forces, and he said, look, quantum gravity is not a candidate to do that. So he said it's the only game in town for that. So of course you need to assume there is a theory that does that. But I think that's important.
Yeah, that's right. And that's, of course, the natural way to think about it exactly when you come from the particle physics tradition, because you already have the standard model of particle physics. And now your problem is to include gravity. How do you do that? Well, you're naturally led as a unique program to string theory, I think. So I don't know. I don't know what this tells us about this case.
Yeah, so this is, I guess, where I'm not sure what to say. I mean, I agree that's the argument that he gives in the book. I'm not sure what the implications are for, I mean, here, I guess, sort of, maybe let me say this. Here, I guess the equivalent sort of stronger, or like the equivalent version of that might be, do we want a theory that's able to account for all of the observations on cosmological cluster and galactic scales? Or do we want just a theory that's able to account for galaxy phenomenology? And like, depending on which one you choose, maybe you'll fall on different sides of the debate. I actually don't necessarily think that even if you restrict it to just the galaxy phenomenology case, that it is that obvious that like cold dark matter is no alternative to MOND, and that you can like construct sufficient argumentation to say that cold dark matter, like that, like MOND really is the only available theory on galaxy scales. So even if you restrict it to that, I don't think the argument would go through. And also, I think that you shouldn't restrict it to that. So there's like two reasons why I think there's this like concern. Yeah.
Thank you. So Mike has a quick follow-up, and then Enrico.
Yeah, so really quick, because I think this is just a possible direction you can go in light of how you were responding to Neil's earlier. One answer to all of this is you've already gone out on a line and committed yourself to a kind of well-fittingness to community practices. And this is, I take it just how Chris was just thinking about the string theory case, which there are community practices within the particle context such that the problem of quantum gravity does sort of have no alternatives besides string theory, with, you know, indexed to that community. And so too, I think here you could just defer, you know, not provide once and for all epistemic arguments about, you know, whether it's getting at the problem of dark matter in the right way, if it is attending to these parts of the problem versus other parts. You get to just say, look, there is a well-fittingness to community practices in observational cosmology and large-scale astrophysical modeling. And so you already, based on what you previously said, I would think have a response to this kind of question.
Yeah. Yeah, and I think sort of like the second part of what I was saying to Chris just now is sort of like going to that, right? Which is like, in our current cosmological practices, what we expect from a theory is to like cover a broader range of scales than just like making this and fitting also with the relativistic models of the universe, rather than just being sort of weirdly restrictive to just galactic scales. Right,
and I would just, I guess I'm just trying to break off that part, as that's going to be a further discussion hashed out about why this particular community practices might be good or might need tweaking. It's entirely separate from the meta-empirical theory assessment conversation in regards to MOND versus cold dark matter.
Right. Okay, cool. Thank you.
Okay, last question, Enrico.
It's very quick. Maybe it's a bit naive, but I wanted to go back to some of the stuff that Chris was saying before, and also Mike was saying. So I was wondering about this, because you said at some point that you didn't want to have the debate being on the fact that let's take a very specific type of dark matter candidate and compare and ask ourselves if it is or is not falsifiable, because then it's quite hard to see whether the evidence that we've gained actually rules out anything or not. If we ask for something like WIMPs or axioms very specifically, what we have got there. And I was wondering this, isn't the fact that the MOND advocate keeps churning out these arguments that dark matter is not falsifiable a consequence of the fact that MOND, in a sense, if I understand correctly how it works, is much closer as the type of theory that it is to something like WIMPs or axioms as a specific dark matter candidate than to the whole cold dark matter idea. And so they keep claiming that, in a sense, dark matter is not falsifiable because they tend to compare their theory with its natural, they would like dark matter as a whole to function like WIMPs functions, because that is the natural compare and contrast with MOND. I don't know if it's clear, but it's like, the question basically is whether or not you think that the arguments that they're putting forward stem from the fact that MOND is much more analogous to WIMPs or axions than it is to dark matter as a whole.
What do you mean by much more analogous to WIMPs or axions?
It is a specific candidate for solving the missing mass problem, let's say.
Oh.
Rather than much closer to saying specifying a dark matter candidate than just a theoretical framework.
Okay, so I don't think that, like, scientifically speaking, MOND sort of on its own sort of qualifies as like a specific dark matter candidate. There are currently sort of hybrid theories in the scientific literature that try to sort of unify I don't know if unify is like, but anyway, try to sort of unify both dark matter and MOND phenomenology, sort of that try to come up with sort of a new theory of dark matter that might account both for dark matter phenomenology and like MOND phenomenology. So one example, I think that, for example, Michaela Massimi talks about is superfluid dark matter. I think that's right. So there are at least attempts at sort of bringing these two together, but I don't think like the current scientific, like MOND sort of as it was conceived of by Milgram and sort of how it is described in the papers that I had here, like wouldn't really qualify for like preferring one particular dark matter candidate over some of the other ones. Yeah.
All right, great. Thank you very much. Please join me in thanking Siska once again.